let us now study about what's meant by wattless current. Okay, so for this we'll consider circuit, okay, in which there is a phase difference of phi between the Vrms and Irms. Okay, so for that I'll draw a picture to show it you. So let's take this as the Irms. Okay, the root mean square value of the current here. It's on the x-axis. Okay, that's why I drawn here like this way. Then we have this Vrms here. Okay. So there is a phase difference of phi between the IRMS and VRMS. We consider circuit, AC circuit, in which there is a phase difference of phi between IRMS and VRMS. Okay. Now this IRMS is we can resolve in two components. Okay, like this way. I'll draw the picture here. This is IRMS. Okay. It's on the x-axis. Okay. And this is the VRMS here. VRMS. Okay. Now this IRMS, and this was a phase angle now. It's a vector. Okay, we can resolve in two components. Okay, that will be, this will be the horizontal component. Okay, you can draw dotted lines like this way. Okay, this will be the horizontal component, that will be IRMS. Okay, horizontal we know always it is cos phi. Okay, and then we also have a vertical component, that will be like this way. This current only we resolve in two components. That is, this vertical component will be IRMS sin phi. Okay, like this way. Now you see the angle between the IRMS or angle between the VRMS. Okay, VRMS is the same now. The angle between the VRMS and IRMS sin phi will be equal to 90 degrees here. Okay, this is 90 degrees. Okay, so now let us see some important terms based on this. Okay, so now we see this thing. Okay, in this picture, IRMS and cos phi and VRMS are in the same direction. Okay, and this we can say this IRMS cos phi is called as the active component. Okay, so first term, that is the IRMS cos phi. Okay, we call this as the active component. Okay, active component of the current here, and then the power in this case will be equal to VRMS, okay, into IRMS cos phi. Okay, and this current is called as a wattful current here. Okay, wattful current. This IRMS cos theta. Okay, it's also called as a wattful current. Okay, this term. Next one, we take this value, IRMS sin phi. Okay, it's at 90 degrees. That means pi by 2 to the voltage. Okay, so this second term will take IRMS sin phi. Okay, this term, okay, we call it as a reactive component. It's called as a reactive component. Okay, and if you see the angle here will be, in this case, the phi, okay, or the angle is pi by 2 degrees. It's 90 degrees to the VRMS. Okay, it's 90 degrees. So in this case, if you see, the power will be equal to 0. Okay, so one minute. In this case, if you see, the power consumed will be equal to 0. Okay, and that's why we say this current as wattless current. Okay, wattless current is a very important term. The power consumed is 0. Okay, this happens where it happens in a pure, okay, inductive or capacitive circuit. Okay, so in this circuit, that means the power will be 0. So what's my wattless current? Wattless current means it's a current in which that the power consumed is 0. Or we say exact definition, the current in AC circuit is said to be wattless current if the power consumed by it is 0. Okay, so if the current, you can see current is a wattless current if the power is 0. This is a very important condition here. Okay, thank you for watching.